Hello everyone. In the course Machine Learning, in the previous lectures, we have learnt about what is artificial intelligence, machine learning, how to design a machine learning system, how to develop a machine learning problem, what are the ingredients of machine learning, namely tasks, models and features, what is the classification of tasks, classification of machine learning models. Today, we are going to learn about the third ingredient of machine learning, namely features, and the process that has to be followed in order to design a machine learning system. Myself, Dr. GNVG Sirisha, working as Assistant Professor in the Department of Computer Science and Engineering in SRKR Engineering College, Bhimavaram. The objectives of today's lecture are, today we are going to learn about what are features, what are the types of features, what are the uses of features, what is meant by MLM dataset, how to construct features, how the features will interact with each other, and finally about what is the process that we need to follow in order to develop a machine learning system. A feature can be thought of a kind of measurement that can be easily performed on any instance. Features are the workhorses of machine learning. Features can be real valued, integers, boolean or categorical. For example for real valued feature is salary, example for integer feature is age, and for boolean feature is medical test. So the medical test can be positive or negative. Example for categorical feature is nationality. What are the uses of features? Features can be used as a splitting variable in construction of grouping models like decision trees, or features can be used in construction of grading models like linear regression model. For example, let f be a feature counting the number of occurrences of the word free iPod in an email, and let x stand for an arbitrary email. Then the condition f of x is equal to 0 selects the email that do not contain the word free iPod. Then a condition like f of x greater than 0 selects the email that contains the word free iPod. So the condition like f of x greater than 0 splits the emails into two partitions. One partition is all the emails where the free iPod has appeared 0 times, and the other partition is all the emails where the word free iPod has appeared more than 0 times. Such type of splits are called binary splits because they divide the instance space into two groups, those that satisfy the condition and those that don't. Non-binary splits are also possible. For example, if G is a feature that has the value tweet for emails with up to 20 words, the feature has the value short for all the emails with the words 21 to 50, medium for all the emails with the words 51 to 200, and long for all the emails greater than 200. Then G of x represents a four-way split of the instance space. As we have already seen, such splits can be combined in a feature tree from which a model can be built. The second use of feature is in building grading models like linear classifier. Recall that linear classifier employs a decision rule of the form sigma I is equal to 1 to n wi xi greater than t, where xi is a numerical feature. The linearity of this decision rule means each feature has an independent contribution to the score of an instance. This contribution depends on its weight wi. If wi is large and positive, a positive xi increases the score. If wi is less than 0, a positive xi decreases the score. If wi is 0, then xi's influence is negligible. Thus, the feature makes a precise and measurable contribution to the final prediction. MLM dataset. Suppose we have a number of machine learning models that we want to describe in terms of a number of properties. The properties we are going to take are the extent to which the machine learning model is geometric, probabilistic, and logical. whether the model is grouping model or grading model. The extent to which the model can handle discrete data and real value data. Whether the model can be used for supervised learning task or unsupervised learning task. And the extent to which the model can handle more than 2 classes. Here we can see the machine learning model dataset. All the rows indicates the different machine learning models and all the columns indicates the properties or the features we have discussed above. So we have the columns indicating the first column is whether the model is geometric model, second stats indicates whether the model is probabilistic model, third one is whether the model is logical model. Fourth column indicates whether the model is grouping model. Fifth column indicates whether the model is grading model. Sixth indicates whether the model can handle discrete data. Seventh indicates whether the model can handle real value data. Eighth column indicates whether the model can be used for supervised learning task. Ninth column indicates whether the model can be used for unsupervised learning task. And the last column indicates whether the model can handle more than 2 classes if present in the dataset. The values 0, 1, 2, 3 indicates the extent to which a particular model has that particular property. A value of 0 indicates the model does not have that property, and a value of 3 indicates a model is highly associated with that property. So from this particular table, we can see that the models like trees and association rules, these two are purely grouping models, because we have a value of 3 here for the trees and association rules. Similarly, we can see that the grading models are the linear models, linear classifier, linear regression, logistic regression, and the GMM. All these are the purely grading models. So in that way, we can understand the properties of all the machine learning models from this dataset. Feature construction plays a crucial role in the success of machine learning application. For example, in text classification, the messages or documents don't come with built-in features. Here, we need to construct the features in order to develop a machine learning model. For example, for text classification purpose, the text documents can be converted into bag of words representation. Bag of words representation is nothing but we select all the unique words from the documents along with their frequencies. But bag of words representation does not consider the order of the words in the email. Then, if a classifier has to be built to distinguish between grammatically correct sentences and grammatically incorrect sentences, then word order is also very important. But our bag of words representation does not consider the order of the words in the sentence. Then we have to go for a different feature construction technique. Another popular feature construction technique is discretization. Here the range of values of a feature are split into intervals and the original feature values are replaced by the intervals. So the real valued feature, which often contain unnecessary detail, can be removed using this discretization. Discretized intervals are easy to analyze when compared to the real values. Another feature construction technique is kernel trick. In kernel trick, we transform the entire instance space into higher dimensional space. This is generally used in machine learning models like support vector machines. Interaction between features. Sometimes we need to identify the interaction between the features. That is, whether the features are correlated or not. What is meant by correlated features? Two features x and y are said to be correlated if as the values of x increases, the values of y also increases or vice versa. In constructing the machine learning models, in that case, only one of the features can be retained and the other feature can be removed, because the presence of both features does not give us any additional knowledge in building a machine learning model. Only one of them can be retained into the dataset, another can be removed. How can we identify whether the features are correlated or not? Here we have another example. If we notice the term lottery in an email, we are not really surprised to find the email also contains the phrase ticket, because we usually find these two words together, lottery and ticket. Ignoring this interaction means we are overestimating the amount of information conveyed by both these words in the same email. So only one of the information conveyed by only one of the words should be used, and the information conveyed by the other word should not be used in such cases. We call such features as positively correlated features. How can we identify the correlation between features? Correlation can be identified by using either Pearson correlation coefficient or covariance values. Covariance is given as 1 by n sigma I is equal to 1 to n xi minus x bar into yi minus y bar, or which is also written as 1 by n into sigma I is equal to 1 to n xi yi minus x bar y bar, where x and y are numerical features. If this covariance value is positive, it means x and y are positively correlated. If it is 0, it means x and y are independent. If covariance value is negative, it means x and y are negatively correlated. Positive correlation means both the variables tend to increase or decrease together. Negative correlation means both the variables, when one of the variables increases, the other variable will be decreasing. If we divide the covariance by square root of sigma x square into sigma y square, we get the Pearson correlation coefficient, whose value will be between -1 and +1. If the Pearson correlation coefficient is less than 0, it means x and y are negatively correlated. If the Pearson correlation coefficient is greater than 0, it means x and y are positively correlated. If the Pearson correlation coefficient approaches 1, it means x and y are highly positively correlated. And if the Pearson correlation coefficient is 0, it means x and y are independent. Machine learning process. What is the process we have to follow in building machine learning models? These are the steps involved. First one is data collection and preparation. So we have to download the existing data, or we need to collect new data in certain applications if required, and then we need to perform or prepare the data for the building the machine learning model. What are the steps involved in preparing the data? We need to clean the data, we need to merge the data, and we need to transform the data before we apply machine learning model. Next comes feature selection. Not all features will help us in building an appropriate model for a particular machine learning task. Some of the features will be irrelevant features. For example, suppose a new music CD is released into the market and I want to build a machine learning model which identifies which customers will buy that music CD. So in this example, features like name of the person or the address of the person or the color of the person will not help me in identifying whether a person will buy the music CD or not. So such type of features are called irrelevant features. Some features are weakly relevant features, means they will not provide us with much knowledge in identifying whether a person will buy the music CD or not. So we need to identify and remove irrelevant features, weakly relevant features, and also redundant features like what we have discussed in the case of correlated features. And we only need to retain the relevant features. That is called feature selection. Third one is algorithm choice. So we have to select an appropriate algorithm in order to build a proper model to solve a particular machine learning task. Next, parameter and model selection. Some parameters of a model are to be set manually. Other parameters called hyperparameters can be determined experimentally by using certain techniques like grid search. Next phase is training. After the parameters are set, we need to build a model by applying this algorithm we have selected on the dataset we have downloaded or prepared. Evaluation. After the model is built, we need to test the model or evaluate the model in order to check whether the model's performance is good or not on the new dataset. With this, we have completed the first part of our Unit 1. Thank you.